Hello, Assalamualaikum warahmatullahi wabarakatuh. I am Nurul Sarashada binti Muhammad Sofian with number matric as 58198. We are from Group 4 and we are going to present our report. Okay, for question 1, download the daily stock price data for the year 2020 from Yahoo Finance. We choose the stock price data for Apple Company and then plot the time series of historical stock price. The data is taken from 1 January 2020 until 31 December 2020. The derivation of three-state transition: E when the share price increase, A when the share price decrease, and R when the share price gets unchanged. P is a probability metric of Markov change. Data for Apple Company for year 2020 consists of 252 trading days with price in state up, which is 137, down 114, and remain same 1 days respectively. This is the data analysis from Excel. Table 2 shows the data of trading days in state upward 137, downward 114, and remain same only 1 days. And table 3 shows the probability of trading days in a year.
Hi, my name is Naim Muhammad Zainal. This is the transition diagram for our data. And the initial state vector is P equal to 0.4453, 0.6667, 1, 0.5474, 0.33330, 0.00730, and 0. For initial state, we need to solve this equation by using the equation as P equal to X and x1 plus x2 plus s3 equal to 1, where x equal to s1, s2, s3. We substitute P from the previous slide and we simplify the equation, and we will get equation 1 equal to s1, equation 2 equal to x2, and equation 3 equal to s3. We simplify again and we will get equation 1 equal to 0, equation 2 equal to 0, and equation 3 equal to 0, where s1 plus x2 plus s3 equal to 1. From equation 3, we get s3 equal to 0.0073x1. From equation 2, we get x2 equal to 0.8211x1. And from equation 1, we get s1 equal to 0.5469. Thus, s3 is equal to 0.0040, s2 is equal to 0.4491, and s1 is equal to 0.5469. And s1, s2, s3 is equal to 0.5469, 0.4491, and 0.0040. For question C, we need to construct transition probability matrix, and we get P equal to 0.4453, 0.6667, 1, 0.5474, 0.3330, 0.00730, and 0.
Hi, I am Ain Ayuni. Now I will be presenting about the calculation of the long-term behavior of the share. Basically, our A node is 0.5469, 0.4491, 0.0040, and the probability matrix of the Markov chain, which is P, is as shown in the slide. Then we calculate the P square by P times P. We will continue by P square times P to find the P cube and followed by P4. Finally, the final answer we got is 0.5469, 0.4491, 0.0040, just like the value of A node that we have. So basically, in long-term behavior, the probability of the company's share does not change whenever the value of n reach a certain level, even when the transition metrics continue to occur. In the long-term behavior or at equilibrium, the transition matrix has no effect on the initial state vector.
For expected number of visits, we assume that the TE is equal to 0 and the total for TE is 1.54. So average step of visit from state E to state A is 1.54. While for the expected number of visits to state R, we assume that the TE is equal to 0 and the total for TA is 1.5. So the average step of visit from state E to state R is 1.45. For expected first reaching time of different state, as the TE is equal to 0, as we assume, we put in the value of average step from state E to state A into the equation of TA. So we will get 1.51 reach time to different state. And for the state R, we will get 1.65 reach time to different state.
I identify the macro trend is irreducible and aperiodic or not. So from the transition matrix, I can know the macro trend is irreducible, and I can notice that state A and E communicate with each other, and state E and R also communicate with each other. And for communication, the state of the macro chain can be partitioned into one communicating class. So since the chain has only one communicating class, it is said to be irreducible. The macro chain is aperiodic. As the given macro chain is irreducible, there is a style transition in the chain, so the chain is aperiodic. For a style state, it is possible to return to the state in 2, 3, 4, 5, and so on steps. GCD equal to 1, so the state is aperiodic. Since the state is aperiodic, the rest of the states of the macro chain are also aperiodic. A class is said to be aperiodic if its states are aperiodic.
Now we move on to question 3b. We are asked to find the limiting distribution and the stationary distribution for this chain. In the previous part, we already obtained the transition probability matrix. To find the stationary distribution, we need to solve these equations, which are pi times p equals to pi and pi 1 plus pi 2 plus pi 3 equals to 1. Then we substitute the matrix into the equation and then multiply it. After multiplication, we simplify the equations and make it equals to 0. Then solve the equation and we will get pi 1 equals to 0.5469 and pi 2 equals to 0.4491, pi 3 equals to 0.004. Since the chain is irreducible and aperiodic, we can conclude that the above stationary distribution is a limiting distribution. So that's all for our presentation of this assignment. Thank you.